I'm still confused with the law of conservation of mass. Because, for example, we all know that wood is used as a source of fuel, and if we burn a log, it changes to ash, and as using our common sense, we can see that the mass of the log is higher than the mass of the ash, and according to the law of conservation of mass, the mass of the reactant is equal to the mass of the product. And we can observe that the mass of the log is higher than the mass of the ash, comparing its size physically. So how can you explain this according to the law of conservation of mass?
Good morning, students.
Good morning.
Today we're going to discuss an important law in chemistry, the law of conservation of mass. This is not the only law of conservation we have. In physics, there is a similar one that deals with the law of conservation of energy. But for chemists, the law of conservation of mass is of paramount importance. It is not well taken by many students as well as instructors, and we're going to discuss the reasons behind this. Who would like to state what the law is? Read it.
Well, the law of conservation of mass states that the mass of a reactant before a reaction is equal to the mass of a product after the reaction.
Very good. It's always required after writing the equation that represents the chemical reaction that it be balanced. Why is it so? Frata?
It's balanced because to make the reaction more clarified and to be more understandable.
I need more clarification on this.
And also to respect the law of conservation of mass.
If you have carbon dioxide reacting with water in the presence of solar energy, which we call photosynthesis, the products are glucose and oxygen. You must, how many elements are represented here? Three. What are they? Carbon, hydrogen, and oxygen. What the law states is you must have equal number of each atom represented. So if you have 6 carbons on the reactant side, you must have 6 carbons on the product side. And that has to be true for every element we see. How about if the reaction is given in the form of ions? The ions could be simple or complex. What else has to be balanced? Maharat? Okay.
The number of electrons?
Yes, but it would be better if you say the charge, because it would take care of both electrons and protons. Even though electrons are tiny, they have mass. I know the masses of electrons or protons are negligible, But balancing the charge protects us from making a gross mistake. If you don't get balanced charge on both sides, then you should try again to do it. There is something wrong. Okay, so we've stated the law of conservation of mass. It looks simple, but many students don't find it that easy. Can you give some reasons why it is so? Okay.
Take rusting of iron as an example. When iron rusts, it reacts with oxygen at first, then forms an iron oxide. At first, the iron had a smaller amount, but the product has a greater mass, so people think that the law of conservation of mass is not true.
So how do you explain this to somebody who comes with this confusion to you? Right?
The oxygen, most people don't see the emission of the gas, so we can help them see the emission of the gas by helping by putting this reaction in a sealed container.
The gas is not being emitted here. Rather, the gas is reacting with the elemental iron to form the rust. So could you...
The rust, we can't see the oxygen, so it's not visible for most people, but we can explain this theory to them.
Okay. What other source of confusion can you raise here?
I don't think I'll agree with this because, for example, if we take a plant seed, at first it's very small when we plant it, but then due to time it grows and it becomes very big. So I don't think the mass can be equal.
So you're saying mass is not conserved? Okay.
I disagree with her because in the process of growing off the plants, there is a consumption of energy. So we can add the total of in the total mass or in the total amount in that process. We can also consider the amount of energy.
The mass of energy?
The amount of energy consumed and that the plant consumed.
Okay, here we have an important thing to clarify. We should not confuse energy and matter here. I know, according to Einstein's law, E is equal to mc squared, there is a relationship between mass and energy. But for chemistry, let's keep that aside. So, when we talk about conservation of mass, it is only mass. Let's not include energy.
Can I correct what I just said?
Okay.
So, as a correction, I can say that there is a mass of the food that the plant consumed.
Okay. Hurt? No, I mean read it. You just raised your hand.
Yeah, I was just about to explain what she said because in order for a seed to grow into that bigger plant that you observed, it had to complete a series of steps. For example, one of them is photosynthesis to observe its food. And the reactants in there are the carbon dioxide, the water we see, and the solar energy we see. These are all reactants. And the water and the carbon dioxide, they all have mass. So if we consider them as a reactant, and if we add the mass to the seed, and if we compare it to the mass of the bigger plant, it is equal. So we are still conserving the mass.
Oh my God, this has been so long since I came to Addis for the first time. It was the summer of 1970, 45 years ago. But the population then was only 450,000. Now we're talking about close to 4-5 million people, 10 times. Where has all this mass come from? We human beings have mass. Radiate?
Well, the food we consume is a reactant, so it helps us grow. So we have to take into consideration, into the equation, the food that we consume in order to grow and to evolve. So that considers as a reactant, and the mass of the reactant plus our mass gives us equal the mass of the product that we have now, the population.
Could you, Fikr, consider this from the following point. When I first came here, Addis Ababa was heavily forested. Now, most of it is gone. How does this help you explain the law of conservation of mass?
We consumed all the trees by eating or by burning them, and they turn into carbon dioxide.
And what happens to the carbon dioxide? Radiate?
I think as plants release oxygen and we also release carbon dioxide as a waste product, equivalent amount of carbon dioxide is released when we compare to the oxygen. So according to photosynthesis, or as you raised, even though plants are deforested, we use them indirectly as a source of fuel by burning the woods or eating vegetables. So it's equivalent if it is that the population has increased.
So you're saying the carbon dioxide participated in photosynthesis to be reduced to glucose, which is the monomeric unit for glycogen or starch that we eat, and by eating this food we grew to what we are now. So the forests that were then are now converted to human forests, if you like to say that. You can take me at a big tree, moving. Okay. What other ideas? Okay.
But I'm still confused with the law of conservation of mass. Because, for example, we all know that wood is used as a source of fuel, and if we burn a log, it changes to ash, and as using our common sense, we can see that the mass of the log is higher than the mass of the ash, and according to the law of conservation of mass, the mass of the reactant is equal to the mass of the product. And we can observe that the mass of the log is higher than the mass of the ash, comparing its size physically. So how can you explain this according to the law of conservation of mass?
Okay, Radiate?
Well, as you stated, when you see only the wood and the product, the ash, it is very obvious that the wood and the ash have different masses. But what you're not observing is that when the wood is burned, it has a reactant, which is oxygen, to help it burn, right? On the product side, the ash doesn't come alone. After the burning of the oxygen with the wood, which is carbon, it will turn into carbon dioxide, and it's a gas, so you cannot see it. But it's still a part of the product. So the mass of that carbon dioxide that has been emitted after the burning of the wood plus the mass of the ash will equal the initial mass of the wood.
So you're saying that even though the mass of the carbon dioxide is negligible, or we cannot observe, the mass of the ash, considering with the mass of carbon dioxide, is equal to the mass of the log. That means the atoms are equal. The particles that made the log and the formation of the ash are equal.
But I clearly did not state that the carbon dioxide is not negligible due to its mass, only because of its property as a gas that we cannot see it, not due to its mass. It still has a considerable amount of mass, but the reason we cannot see it is not because of its negligible mass, but because of its physical state as a gas. If we were to compress it and see it, and restrict it, it would have a considerable amount of mass.
Okay. When living things die, what happens to them?
They decompose.
Yeah, Maharat?
They decompose.
They decompose. And when they decompose, they disappear. You don't see them the way they are. when I die, there will not be tatanka anymore. Okay? But I am replaced
By plants.
Do I become a plant
No.
right away?
No. When you die, you decompose into different nutrients and enzymes that helps plant grow. So hence plants grow. So you could.
So I become soil.
Yeah.
Yeah, there's a religious saying, ash to ash, soil to soil, earth to earth. And we believe, if you are religious, that we were made from soil. So when we disappear as living things, we become non-living, but still we are there. The carbons that were in me. Maybe if you can find this to be interesting to you as students of science. I went to London, and I sat by the graveyard where prominent scientists, politicians of England are buried, and I happened to be very close to that of Isaac Newton. And there was an apple tree. I ate one of the apples. Maybe I have some atoms that were his that are in me. And when I die, I don't know who lucky guy takes. It could be a fish or another plant, I don't know. But we are recycled. But nothing disappears. We come in different forms. So it's sort of recycling. Okay, who put all this knowledge in this beautiful form that we call the law of conservation of mass? We should give credit to scientists. Yes. Lavoisier. Where was he from?
France, I think.
France. Okay. No, he was not from Ethiopia.
Yes.
Okay. So what kind of experiments did he do that helped him see that this leaf?
He burned a tin in a sealed glass, and then later he measured the mass on the side of the reactants, and after the product, then the masses became equal. So we stated the law of conservation of mass.
It is clear?
Yes.
Do you think you can explain this to a novice, a student who is studying chemistry for the first time? They come with lots of confusions, as we all did. We still have our own confusions, but we are much better than when we started. So, are you comfortable now with the law of conservation of mass?
Yes.
Or do you have any question that you would like to be answered by your friends here?